Hello, my name is Arvind. I'm Senior Engineer, American Express. I'm here with my colleague, Junk. We are here to present and give an insight into a little framework which we have built within American Express, which is a configuration-driven reporting framework, which generates report based on a dynamic input provided to it on a large data set using Apache Spark as the core product. Now, before we deep dive into the topic, a quick word on Amex. We are a financial services company which provides card and digital products ranging across financial services, business travels, network and merchant services. We provide digital services and products for all of these capabilities here in Amex. Now, jumping into the agenda, we will start with a quick introduction on the reporting framework. We will go through the need of why we need such a framework, which works on a dynamic configuration based. We'll go through the components, we'll go through the design, we'll understand what level of transformations we need in this kind of a framework and how we can manage those transformations external to the actual framework. Same applies for a template, because the reports at the end of the day work on top of a template. How can we manage those templates and how can we use those templates externally to the reporting framework so that we can come out with a reusable framework, which again needs to work on top of a big data. So this is a quick introduction to the framework. This framework works along with a dynamic scheduler, which we have built, which is external to the framework again, and it internally does a transformation, aggregation, filtering of big data. And the reason we have used Spark is to leverage that in-memory and the parallel processing capability of Spark internally to the engine. Now, a quick glance on the statistics and the general need. I mean, why we feel a need for this kind of a framework. Here in this division of Amex, we have billions of records getting ingested into the data lake each day, and we have requirement of various kind of reports. It's a partner specific report, so we have to give that partner flavor or the partner level configuration to the reports. We have generic reports. Again, it's a generic report collecting a lot of partners information. We generate thousands of reports daily. We have hundreds of monthly reports, so there is a bit of an aggregation on a daily basis to generate those monthly reports. The report can be a feed, can be a summary of an extraction. So there is a lot of different kind of need on a report. Now, if we want to cater to all these needs on a need by need basis, then we will have to write a lot of code. So what we sat down and thought is, can we create something like a framework, or can we create something like a reusable component? Now, that led us to the need, right? The pattern evolving. So when we go through the needs of the reporting, there was two pieces of pattern involving. One is we have different reports and the feed needs. We have different kind of stakeholders. We have different partners who have different frequencies for their reports, who have different input data set for their report, who have different aggregation rules for the reports, and all this, or on top of all this, there is a different template. So we have PDF as template, we have normal text file as a template, we have very customized template as well in which the report would go. So these are the different criterias for the report. At the same time, when we went through the requirement, what we saw is we 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 have a common pattern evolving. So when I tell a common pattern evolving, we had the input data set in the same format. We always use Parquet as our input data set. So when I look at my framework, I can go to a Parquet location and read that. So read part is a common pattern. Now there are reports in which, along with the input data set, I might have to look up to an external data storage and enhance the data. So that's kind of a common pattern. Can I have a flag based approach to tell, yes, for this report I can look into external storage, and can I give a lookup data set name so that it becomes seamless? Now, one thing which was constant in all our report was a sequence of transformation rule. So can I pass this transformation rule dynamically into the framework? So the framework's only job would be to look into the transformation rule and apply the transformation rule on top of my data set. So these are some of the constant common pattern which was evolving. Now, at the end, I have a template. Can I provide that template as a file or as a configuration external to the report? And then the report can just blindly apply the template on the data set. So we have different configurations of parameters at one hand, and we had a common pattern evolving. So what we thought is, can we control these external parameters or the different parameters dynamically, which is external to the reporting framework, and run it on top of Apache Spark as a job? That would kind of give us a common reporting framework. So this was the pattern, this was the theme, this was the design thought which was which went into this architecture. Now, when we applied this and we thought through the architecture, this is what it came up with. We had this is our technical component. Now, if you see in the middle box, the middle dotted box is our core reporting framework, which is a reusable component. So we have a Spark job, which we have a application, we have a Java application written, which runs on top of Spark, which expects to read a specification file, right? So the heart and soul of this framework would be this specification file. This will guide the entire framework to do what it needs to do. Now, once it rates this, it knows the step of activities it will do. So it prepares the initial data set, it looks up the data, it applies a set of transformation rules, which is written in the reporting spec, and it applies the template. The template is a file which is provided to it, right? Now, this is the core framework. Now, to provide that dynamism into this reporting framework, we had to keep this spec or the configuration external to the framework, so that when the job spins up, it can go and look into the reporting spec. So we leveraged the HashiCorp console product, which is our config management product. We have a solid pipeline for that, which we leveraged, in which we could push this spec external to our framework to a config location. So that became our config management system, which will drive the configurations for my framework. Now, how do I spin up the job in a scheduled manner? Because each job is to generate a report. So we leverage a Kubernetes scheduler app. So we have an app running in our cloud platform, which is backed by a Kubernetes scheduler. We had those partner information and partners schedules maintained in the scheduler, which will read those schedules processes and spins up a Spark job. Now, while it spins up, based on the report it is spinning up, it would pass those dynamic reporting credentials to the Apache, to the job dynamically, so that the job knows which reporting spec am I looking at, right? So it will pass that, and that gives all information to my job, and my job knows which location of my config product my spec has, and it will go and read that, and then it behaves it. Now, finally, after doing all the stages, and we will deep dive into the stages later part of this presentation, where we will give exactly what kind of rules we are looking at and how will we apply those rules to the framework. We have a full-fledged deep dive into that, but it applies all those steps, and then it applies the template on top of the data. Once the template is applied on the data, the report is generated and it is published through a S3 bucket, which we have, which is basically the storage area for our reports for our downstream transformation. One quick thing which is relevant to mention here, and again, we'll spend some time later part of the presentation, is we have used a template engine, which basically reads the template and which will apply the template on top of a data set. And we have used FreeMarker. Again, we have evaluated it a lot. Since our language we have choose was Java, it was fitting well with us. So we choose that product. And yeah, I mean, these are basically the different components which brought in the dynamism into the configuration entire framework. Now, I'll hand it over to my colleague Jung, who will give you a deep dive into each of these components. So we'll spend some time on each of these components to understand how we are doing what we are doing. Before that, a quick glance at the configuration file. Basically, it's a JSON file which we are maintaining, which has various information or various specifications defined. Starting from the reporting name, there is metadata like title, type, ID, which will be used for logging, auditing, tracking purposes to bring those uniqueness to those reports. We have a schema defined. Basically, schema is nothing but not all data in an input data set is used in all data in all reporting. So we have a schema which is defined, which will tell that the subset of data which will be used. We have lookup data sets, which will basically tell the lookup data set which needs to be used in my input data set. Then we have the transformation rules. Basically, these are the rules which will transform or which will change the data set based on the reporting needs. Then we have a reporting template, which is an external template which we have provided, which the template engine uses to create the report. Then we have schema, the definition of the schema. Now, throughout the course of the session now, we will refer to a configuration file, and we will tell you how each of the elements of the configuration file is driving the different stages of the reporting. So without spending much time, I'll hand it over to Jung. Jung, over to you for deep dive.
Okay, let's go to the deep dive session. So the first step will be the data lookup stage. So after we read the Parquet files from HDFS, we have our original data frame. But for each report we want to generate, we just need to use a subset of columns that in the original data frame. That's the reason why we have this apply schema stage. So you may have questions about why Parquet provides so many columns, but our reports only needs part of it. So the reason is we need to use this Parquet to generate different kinds of reports or feeds. So each report or feeds requires different columns. So, and also the schema here is just a list of column names that we can get from the configuration file. After getting the list of column names, we can build a SQL query from it. So here's one example. There are 4 columns in the original data frame, and after applying the schema, you can see the schema over there. The data frame with 2 columns, which are specified in the Spark SQL query, is returned. So in this way, we can reduce the size of data frame at the beginning, which will also save some computing time later and resources. So this is our apply schema stage. And the next one will be data lookup stage. So after we apply the schema, we may still find some info which is needed by the report, but not provided by the Parquet itself. So that's the reason why we need this stage. But we can find the how to look up and what to look up in the configuration file also. So we're talking about the configuration file all the time. So this is the most important thing in our framework. So for example, here, we may need to look up from Cassandra table and get a data frame. So that's the sample lookup in the slide. And after we have that lookup data frame, we can join it with the original data frame based on the common key and have a new data frame created. After this step, we'll have all the data that is needed for the report generation. But still, we need to process the data and do some calculation because before it can show in the template. So that's the reason why we have this applying transformation rule stage. So because we need to aggregate the data at different levels. So each time we do aggregation group by several columns, a new data frame is created. A report may need several data frames. So by applying transformation rule stage, we need to create data frames from 1 to many. So other than aggregation, we may also need to filter out some rows or apply some rules to the data. So we can also get the transformation rules from the configuration file, like step 1, step 2, step 3, in the example. So from the example, you can see the original data frame, we have 11 columns here and 11 rows here. And from step 1, we want to get the rows with transaction ID smaller or equal to 10. So after executing step 1, a new data frame is created. And you can see from step 2 and step 3, we want to aggregate the amount by different fields from step 1's data frame. So for step 2, for example, we grew by category ID. And for step 3, we grew by transaction type. So it will return us with different values and different aggregation. So this means we have different aggregations in different levels. So, and all this data frame we created by these steps may be used in our template. Okay, and also we not only use the function that is provided by Spark itself, but also we use some user-defined functions in our transformation rules. So here's our 2 main UDFs we're using mainly. So the first one is decimalize. So basically use it to calculate the actual transaction amount. We calculate the transaction amount by getting the value from the transaction amount column. And also there's another column, which is decimalization factor columns. So then we just calculate the actual transaction amount with these 2 values, the 2 column values. So that it needs 2 parameters. One is the amount, which should be an integer value, and the other is the decimalization factor. And also the second UDF we use mainly is signage. So basically we just apply rules to change the transaction amount to positive or negative. So all these 2 UDFs we're using mainly to prepare the data before aggregation. And also then the next step is to apply a template. So we know that to generate the report, we need to apply the data we calculate using Spark to a template. So finally, since we want to show the data from in the template, right? So that's the reason why we need to apply the template. So here's 2 examples we need to resolve. The first one is since we're writing code in Java, and we need to decide which Java template engine we should use. And the second problem is how to transform the data so that it can be used in the template. For the first question, we have researched on several template options. For example, velocity, time leaf, string template, and FreeMarker. For velocity, it actually meets our requirement to generate the report, but we know that it will soon be deprecated by Spring, so we didn't choose it. And for time leaf, I think it had the same functionalities as FreeMarker and velocity, but uses a different syntax that claims to be a little cleaner, and it's also specifically support certain template types. And also it's used, it has a wide popularity. But the problem is it does not release frequently. So the most recent 2 releases have a 2-year gap. And for string template, so we know that I noticed that the documentation there is not robust, and the framework is less stable. So we just don't want to use it. And finally, we decided to use FreeMarker as our Java template engine. So it is a template engine for generic template, and also supported by Apache Software Foundation. And it widely used across Apache projects, and it has new frequent releases also. So the latest one was in February 2021. And also it has good documentations and community. So if you find a problem, you can search online and easily find the answer. So for FreeMarker, so let me introduce FreeMarker a little bit. So FreeMarker is a Java template engine to generate text-based reports on template and data. So template are written in the FreeMarker template language, which is actually a simple language we can use. And we just need to prepare the data, and then the FreeMarker displays the prepared data using the template. So in the template, you're focusing on how to present the data. And outside the template, you're focusing on how the data will be presented, how to prepare the data. For this case, since we're using Spark to prepare the data, so here comes the second problem, how to transform the data so that it can be shown in the FreeMarker template. So our solution will be to transform the data frame to a dataset with Java bean type, and then transform it to a list. So, and FreeMarker supports to traverse the list and show the data in the list. So here's one example. From the template side, you can see that we can traverse the list provided by Spark, and each member in the list is a Java object. So previously, it was, if it's in the data frame, it will be a row. And each of the fields can be referred by using the dot. So after we send the data and the template to FreeMarker template engine, and the final output is shown there. So it's printing out all the necessary information, and it prints out all the data inside our original data frame that we referred to. So this is our deep dive of our reporting framework. Let me give it back to Arvind.
Okay, thanks, Jung. I think so. Just to quickly summarize what we talked all through here, and what was our purpose of showing it is, if you can provide those configurations external to the framework will be reusable. And here, how we managed is we managed it through a config management system, and we constantly look up for each reports into the config management system and let the config drive what the reporting framework does. Couple of benefits we saw using it is because we made it a black box and we shipped it as a framework. Our overall build time reduced substantially because the framework is intact. All we have to do is we have to change the configuration file based on the reports getting generated. Now, the other big benefit is the actual teams, because there are a lot of different teams using a lot of different type of reports. Being the report framework team, we build the framework and we ship it across, and the actual team using it need not know the nuances of the reports. So we really don't need a highly skilled technical team with knowledge of Apache Spark and all those things to build a simple report. And and we were also able to process big data ranging from tens and millions of reports to get records in one report. So that's a performance. We're constantly striving to improve the performance. We do see certain bottlenecks in terms of the the download aspects and the transmission aspects, but constantly thriving to improve those things. So those are a couple of challenges I would upfront suggest. Because there is a list piece involved, it comes with a challenge of downloading it. But then if you can do it, I mean, if you can have those pointers and have those the data evaluated and the resources and your underlining availability of the resources upfront planned, and that's kind of for any Spark based application, you will have to plan your resources way ahead. So if you plan that ahead and you have those planned out, this framework will give you those benefits and supports which we want. Thank you so much for listening to this presentation. Feel free to get back to us if you have any questions. And we at Amex are hiring for our needs here. So feel free to please log into the Amex job portal. And yes, thank you and bye-bye from me and Jung here. Thank you.